When I teach my astronomy classes, one of the hardest things to get students to remember and comprehend is the huge range in sizes and distances in our universe, especially as they relate to our own human size. We humans live at a scale of about 1 meter. That is, if you hold your arms up and out above your head, distance between your two hands is about a meter, a bit more than a yard or 3 feet. So if we line up 10 people holding hands, the distance is 10 meters, or about what's needed for a first down in American football. 100 such people would stretch across the whole football field, about 100 yards or 100 meters. Now, as it turns out, the meter was originally defined as 1/10 millionth of the distance from the Earth's equator to one of its poles. So 10 million people, roughly the population of Greater New York City, holding hands would stretch from pole to equator, assuming they don't freeze or drown. Counting the zeros shows that 10 million is just 10 times itself 7 times, or as scientists say, 10 to the power 7. Now, if we think of each power of 10 as like a rung of a distance ladder, from humans to Earth is a climb of just 7 rungs. By our modern travel in cars and airplanes, we all have an intuitive feeling of this jump from us to the whole wide world. This makes Earth an excellent bridge from us to the cosmos, since in addition to being our home, it is, after all, one of the planets in our solar system. Of course, it's actually a relatively small planet. The largest, Jupiter, is about 10 times bigger, meaning that it is just one more rung of the ladder, 10 to the 9 or 100 million times our meter size. But the Sun, in turn, is about 10 times bigger than Jupiter or 100 times Earth, and so 10 to the 9 meters, or now a billion times bigger than us. Of course, it doesn't look so big in our sky because it's quite far away, about 100 times its own diameter. This mean distance between the Earth and the Sun is called an astronomical unit, an AU. It's thus just about 10 to the 11 or 100 billion meters. So even all of the roughly 10 billion people on Earth holding hands would only reach to about the tenth of the distance to the Sun. At the fastest speed possible, it takes light about 8 minutes to reach us from the Sun. But from the nearest other star, it takes light 4 years, meaning it is about 4 light years away. A light year, the distance that light travels in 1 year, works out to be about 100,000 astronomical units, or another 5 rungs in the ladder. Being so much further away, it's no wonder that distant suns seem so dim and puny compared to our own brilliant star. But our sun and the stars nearby are only a few of the several hundred billion in our Milky Way galaxy, spread out over a diameter of about 100,000 light years, another 5 steps, or a total of 10 to the 21 times our meter size. Then, with another jump of 5 steps, we come to the size of 10 billion light years, almost the maximum distance light has been able to travel in the 14 billion years since the Big Bang. The universe might well be infinite, but this thus represents the size of the observable universe, 10 billion light years, or a total of 26 rungs in the ladder from us. To keep track of this progression, it is helpful to think of it like a 7-digit phone number, 7112555, representing the progression from us to Earth, to Jupiter, to the Sun, to the distance to the Sun, to the nearest stars, then to the size of our galaxy, and then even to our whole observable universe. But in addition to this progression upward to the cosmos, let's consider also the steps to smaller sizes. We humans are made of billions of cells, each of which is about 10 micrometers, or 1/100,000th of a meter, so 5 ladder rungs down from us. Then another 5 steps down takes us to the size of a single atom, a tenth of a nanometer, or 1/10 billionth of our own meter size. But an atom is mostly electrons buzzing around empty space about a tiny nucleus, another 100,000 times smaller, or 1 femtometer, also known as a Fermi, 10 to the minus 15 meters, 15 ladder steps down from us. For these smaller scales, we can thus just add a 555 area code to our phone number. With the extra 15 steps, we thus now have a total of 41 ladder steps from the nucleus to the observable universe. The smallest size we can imagine in our current physics is called the Planck length, some 20 steps smaller than the nucleus, at which gravity and all other forces of nature melt together, leading to a kind of quantum foam in the domain of string theory. But experiments in this domain require very high energy accelerators, and so far the most powerful of these, the Large Hadron Collider in Europe, has only been able to extend to a scale of the Higgs boson, just a few hundred or a bit more than 2 ladder steps below the scale of the nucleus. To get to the next potential landmark, the Grand Unified Theory, or GUT scale, in which all the forces besides gravity are thought to merge, requires another 14 steps in size, or 100 trillion times higher energy than the Large Hadron Collider. Some worry that there may not be much to find in between, a kind of size-scale desert. So for now, if we just stick to adding a +20 country code, the code for Egypt, we have in all an 11-digit phone number for the key levels along the now 61 steps from the Planck scale to that of the universe. 20 555 711 2555. The universe's phone number, taking us from the smallest to the largest scales possible.